Good afternoon and welcome. My name is Antti Havulinna and I work for LG Electronics Finland lab. Today I'm going to present you our work that we did on a full chip RFIC transceiver co-verification methodology using system variable real numbers. So the motivation for this work was kind of twofold. The primary target is to enable the verification of the RF transceiver with the firmware, which is the software included. The development of the firmware has always been done in parallel with the hardware, but the verification part is usually left until the hardware is out from the fab. The secondary target is to enable better verification coverage. So we basically target 100% coverage, which essentially will let us to catch hopefully more connectivity bugs, power domain bugs, and most importantly accomplish the complete operation mode functional verification. So we need to verify all the operation modes and the signal paths. And the chosen approach to do this is to model the complete IC in full HDL. This enables us to use a digital simulator like the Cadence Incisive, which gives us the speed, it's fast, it's portable, and we can actually hand over the RFIC, which is essentially analog, to the SoC team for their integration and verification purposes. The previous generation RFIC was described in a similar language, VHDL-RN, with record types. The reason for moving over to system variable real numbers is the fact that the VHDL-RN was not that well supported by the different vendors, while system variable real numbers is a real standard, and it has a high attention from industry and can be used also as a test bench language. We have also utilized the UDT and UDR, which are the user-defined types, and I will show you some of the results that we gain by doing this. So how do we do the models is with the help of something that Cadence provides, which is the Schematic Model Generator, or SMG. It's part of the Virtuoso product, and it allows the analog users to use their familiar Virtuoso schematic environment, picking specific building blocks from a toolbox and putting them together, and then just hitting a button to generate the actual system Verilog code. This way, the designer doesn't necessarily even need to know what the code itself contains. So, where are we? We have a typical test case using this methodology that we run in a few tens of minutes. And the longest test case without the UDT modification is around 2.5 hours, which is already pretty good compared to a full day or several days of fast-price simulation. But when we use the UDT, especially on the RF signals, we actually get down to less than an hour of simulation time, and this is the heaviest simulation, so to speak. So this is what we have developed. Thank you for listening, and if you have any questions, please don't hesitate to contact me.